So we left off with completing this example. So this example wasn't too bad, but we did combine a whole bunch of different aspects of programming that we already talked about. Believe in this program specifically, we had to have a loop. We had to use input output. We had to use conditional statements. We had to use, and then like also utilize lists, all combined in one programming module. So the next thing that we're going to do is loop through lists. So this is a very common algorithm that you will be required to know, especially depending on what, if you decide to do computer science, especially if you're going to be taking AP Computer Science A next year or in the following years, you will 100% have to know this. So given a random list of numbers, or I guess a list of random numbers would be a little bit more accurate. Given a list of random numbers, you have to find the largest number. So unfortunately, how Python or how any computer program works is a little different from what you would expect. When you're given a list of numbers, so let's say I have our list for random list is equal to, and then just have a, we just have our list of like 7, 12, 9, 11, 6, and 4. When you look at this, you as a human being, you as an individual are able to just look at this and see, oh, 12 is the largest number because it's greater than all of the other numbers. Thus, 12 is the largest number. However, Python doesn't have, or most computer like softwares or most interpreters don't have the ability to look at the entire list in its entirety. It could only look at a value at a time. So it's almost as if I were to give you this screen and just say, hey, what is the largest number of this list? You wouldn't be able to see the actual list, but you could see one number. I could present one number to you at a time. That's pretty much the task that we are giving to Python, which is going to make things a little bit more difficult. So let's go ahead and throw some ideas around and see what we can do. Let's say I have a list, 1, 7, 11, I'm going to use random numbers now, 15, 3, and 9. Sorry. So you are given a list, or you give Python a list. Python can only see this number. This is pretty much how you want to. Oh, can you guys still not see the screen?
We can see it.
Yes, we see it. Okay. All right, if you can't see it, I don't know when that message was from, but if you can't see it, just maybe exit the meeting and try to re-enter, and hopefully it'll fix itself. That's the best I could offer, unfortunately, at this point. But let's say you're given a list and you want to figure out what the largest number is. You can use the strategy of looking at one number at a time and keeping track of what your current largest number is. When you see the first number, or I guess when we say the 0th index of the number, we can see, oh, this so far in my list, this number is the largest number. So I will say that 1 is my largest number. Then I'm going to move on to the next number, where I see 7 at index number 1. 7 is larger than our current largest number, which is 0. So what we're going to do is say, well, 1 is no longer the largest number. 7 is our largest number. Because 7 is larger than our current maximum, then we have to move on to the next number. Because we don't know when we'll find the largest number could be here for all we know. We don't know because we don't see all of the numbers. We do unfortunately have to go through the entire list. So in this case, when we look at the number 11, which is at index number 2, it is larger than our current maximum of 7. So we are going to replace the 7. It's no longer our largest number. Our largest number will now be 11. Doing the next one, the next index, taking a look at the next number, which is 12, we can see that 12, which is at index number 3, is larger than our current maximum, which was 11. So now our current largest is 12. Then if we look at the next one, let's see, this next one, 15, which is at index number 4, it's larger than our current maximum. That will be 15. The next number is 3. And we take a look at the number 3, which is at index number 5. 3 is not bigger than our current maximum. 15 is definitely larger, so we don't make any changes. 15 is still our largest number. And when we finally look at our very last number, which is number 9, at index number 6, then we can see because 9 is smaller than our current maximum, 15 indeed must be our largest number. Because we've exhausted all the numbers of our list, we can see that it's the last number standing after going through the list. And since it hasn't been replaced by a different number, our maximum will be 15. So when we think about the algorithm in which that we use in order to do this, we think about the structures that we will be required to build this. We need a loop, first of all, because we need to loop through all of the numbers. We have to see every single spot in our list. We need a condition. We need to be able to see which number is bigger. We need to see which number is smaller. We need to make replacements if needed. Maybe we need other little things here and there, like temporary variables, that we will get into in a moment, though. We have to figure out where we place certain things so that our algorithm properly works. So let's go ahead and program this. Can everyone see this? Perfect. So this is to find the largest number, the maximum value of a list. So we already talked about one of the things that we need is to loop. We need to loop through all values. We also talked about a condition. We will talk about what that condition is, and we also need to consider the placement. So let's say we have a list. Our list of random numbers at this point is going to consist of these values, or let's throw some random values, 8, 3, 4, and 90, 32, 25, and 8. We're good. Yeah, we'll just throw an 8 in again. So because we have to loop through all the values of the list, we also have to think about how are we going to loop through all the values in the list? What kind of loops can we use? Remember that we have 3 different loops that you could potentially use. You have a while loop, you have a for loop, and you have a for each loop. So we have to think about which one would be best suited for our needs. Let's see, let's try taking a poll and see which, what you guys think. which loop. Remember, we have a while loop, for loop, and a for each. So go ahead and submit your opinion. Okay, we'll just go ahead and end the poll right here. So there technically was no wrong answer for this. For our purposes, you can use any loop you want to. You could start at the beginning of the list, you can start at the end of the list, but as long as you go through all values of the loop or all values of the list, it doesn't matter. So you could use any of these. Here you can use loop. So there was really no wrong answer. It just does seem that most of you guys were leaning more towards the for loop. There was no one that voted for the for loop at first. I was a little shocked, and then all of a sudden, like everyone started to vote for the for loop. But it doesn't matter which one. I think just for simplicity, as it's our first time, we are going to do a for each loop first, and then I'll show you how to do a for loop after. So we have to go through each number in our randomized list. For each number in the random list of numbers, you want to compare. You want to see what is your greatest number, which one is your current largest number, pretty much. So you have to check if your current, make a comparison between your current maximum and with your current number. So when we did the algorithm, there was a lot of comparison. I said, this number is bigger than this another number, therefore we had to make some kind of change in our current maximum. So if maximum blank number, where we have our blank, are you guys having issues seeing the screen? Everyone see what I'm typing? Okay. Okay. So if you're having issues seeing the screen, try maybe exit the Zoom and then re-enter the Zoom. I'm not too entirely sure what exactly is going on today. Just might be because I'm using hotspot. But if maximum blank number, then we want to change what does this comparison have to be? If maximum greater than number, if maximum less than number, greater than or equal to, less than or equal to, equal to, not equal to, what would best suit our need here? When would you want to switch things around? Or when would you want to replace? Right. If your current maximum is less than the number that you are looking at. If your number is greater than the maximum, then that deserves to be your new maximum. So you want to change your current maximum, and the maximum should be equal to your number. If you decided to use less than or equal to, that would have worked as well, because if maximum and number were equal to each other, then you would just set your maximum to the number again. So it's not a big deal if you have it or if you don't. In terms of your end result, you'll get the same thing. Here's another question for you. What should maximum initialize? What should maximum start off as? We're talking about comparisons every single time. You compare this number with this number with that number, but we need to know what to set maximum equal to at the very beginning before we do all of these comparisons. So, does anyone have any ideas? Someone said, so if 0, what if I change this number to, what if all of these are negative then? So if all these are negative, we can't use 0 as our current maximum. Otherwise 0, which is not part of the list, would be our maximum. So the best thing to do is to make it the first statement in the list, or the first value in the list instead. So our list 0. That is the ideal thing to do. That way, all values inside of your list will be compared to values in the list. You're not making up a value to compensate. If you're familiar with math libraries, you could also use positive infinity or negative infinity depending on your needs, but I haven't introduced like the math library to you guys yet, so don't worry about that. But if you are already familiar with math libraries and how to use like positive infinity and negative infinity, that's perfectly fine. You can use that instead of initializing it to something in the list. So now your current maximum, because that's the first thing you're going to look at, is going to be the first value in the list. And that's just typically the easiest thing you want to do. As you go through and iterate through the rest of the list, you can switch up the numbers or switch up the maximum as long as it fits the condition that the current number that you're looking at is larger than your current maximum. Just to test, let's go ahead and print maximum. See if we do get the correct number. So we can see in this case, after we run it, the maximum is 90. If I change this to negative 90, then our new maximum should be 34, I believe. So if I run this again, we can see that our maximum becomes 34. If everything is negative, however, you can see our maximum in this case would be -4 because that is our least negative value of the list. So this is how you want to find a maximum from a list, like a maximum value, numerical value. But let's say change it up a little bit. Instead of asking you about the maximum value from the list, I want you to find the index that holds the maximum from a list. So in this case, that means we cannot use a for each loop. The for each loop doesn't look at each, or it looks at every single value in the list, but that's what it does. It looks at every value in the list. You can't easily, and you could get the index numbers by using it, but if you have duplicates, then it becomes a little bit more complex. So you don't want to use a for each loop. Avoid it because of the fact you don't use the index. Instead, you want to use a while loop. To that way you can see what index what index actually could hold the maximum value instead of what value is the maximum value. Using the same list, let's just go ahead and copy and paste this list. We can change it up a little bit later, but since we want to keep track of the index, does anyone have any suggestions what we should do to keep track of maximum index, or the value, or the index holds the maximum value? Any suggestions? How can we keep track? Well, how do we keep track of our maximum, our current maximum? Yes, so we kept track of the maximum by having a temporary, or like a variable that literally kept track of it. So we can easily do that with the index value as well. So we can call this index max is equal to something. We'll talk about that. And what this will do is keep track of the index that the largest number. Which brings me to a different question. Do I need oops. Do I need maximum? Do I need a temporary variable maximum now? So I'll just let the last remaining like 40% of you guys vote. Okay, so most of you guys said that we do need the variable maximum, and actually that wasn't like by a large margin, but some of you guys also said no. So if you decided to have maximum, it will still work. You could, without maximum, you could correctly get you could get the right answer. However, you don't actually need it. Because you're keeping track of where the maximum is, you could also access the value using the index and also using the brackets. So let's go ahead and try it without using an additional variable other than index max. So we're going to use a for loop since the for loop seemed popular. So for each index in range of the length of our list. Remember, when we write out our programs, we want it to be flexible. We want it to be able to interpret any list that we give it. So I should be able to add values onto our list or take away values from our list, and this should work flawlessly. So don't hard code in a number, like for example, like 35 or like 2, unless it's known that your list is not going to change. So for each index inside of my list, I want to see if the current number in our list is so if you want to get the current number, just get the current number by using the brackets. So the current number will be our list bracket and then index. That is how we get our current number. How would we get the current maximum then? Just by using the one variable that we were provided, index max. How would we get current max? How would we get the current max every single time? Right. Same thing that we did right here. We're going to use the brackets. We use our list bracket index, the index of the maximum. And that will give us access to what our current maximum is. And if the current number happens to be greater than our current maximum, then we're going to replace the indices. We're not going to replace the values. We're just going to place a marker at where our current maximum is. Index max. And like before, our index max should be 0 because it's the very first index of the list. Up here, we actually initialize our maximum to the first value of the list. Here, we're going to just initialize the index as the first index of the list. So if instead, I'm just going to print out maximum index of maximum, And this is going to be the index max. We could also see what the actual maximum is given the index max, which we can access by putting it inside the brackets. If I run this, we can see that the index of our maximum is 1, 1 being index number 1, and the actual maximum itself is -4. If I add in a couple extra numbers like 100 and then like 72, 36, and 1, you can see that the index of the maximum has changed as well as the maxima itself, despite the list becoming a different size. Once again, we were able to program in some kind of flexibility by having this in here instead of hard coding in the actual indices that will appear. When we talk about the actual indices themselves, this is index number 0, index number 1, index number 2, 3, 4, 5, 6, 7, 8, 9. This is index number 9. So our maximum number is there. We can see that the last 3 values from the last 3 indices of our list are not as big as our actual maximum, which is 100. So our program seems to work correctly here as well. Okay, let's do one more question, or let's just do one more programming example together. So odds only. Given a list of positive numbers, remove all even numbers. So this is where things get a little bit tricky. So let's say I have a list. There's a couple of options here. So first option is kind of like what we did in our strings, where we did string concatenation. Instead of string concatenation, you could do list appending. So make an empty list. This is one option you have. Then append all values that you want to keep. So for example, if we have, so in this, like if we use this example right here, I create my empty list. If I look at this number, I want to remove all even numbers, which means I want to keep odd numbers. So I look at the 1 and I say 1 is an odd number, so I will add it to my list. So I have 1 in my list. The next number is 2, but 2 is even. So I don't want to keep 2. I want to remove it. So instead of physically removing it from the list, I can just not append it to my new list. Then I see the number 3. 3 is odd. So I will keep it, and I will keep it by appending it to the new list. And then 4 is even, so I remove it by not appending it to the new list. Then I have the number 5, which I want to keep. So 1, 3, and 5. 6 is even, so I don't want to add it to the list because I'm removing it. Then I have the number 7. Oops. I have the number 7, which I want to keep. So 1, 3, 5, 7. And hopefully you guys can see the pattern. You keep whatever you want to keep, you append to this new list. Whatever you don't want to keep, you just leave it. You don't do anything with it. That's your first option. The second option is to actually just remove it from your list. So option number 2, which I'm going to write up here, now you have to be careful with this, unfortunately. So remember, we also last week talked about 2 different methods you can use to remove things from the list. We have .pop and we have .remove. When looking at .pop, actually, let's just go to that slide. Oops. That's not it. I went too far. Okay, when we do .pop, if you don't put anything in here, you will get an empty, or you will remove from the very end of the list. If you put something inside of the parentheses, then what's going to happen is that you just remove the index, whatever values in the index. But if you use .remove, it removes an actual value, like the actual element from the list. The risk that you run between using .pop and .remove is that for .remove, you might have 2 of the same instance. So for example, 1, 2, 3, 1. If you do list.remove 1, and you have 2, it might not remove the one that you want. The one that it will remove is the first one that it sees, and the first one that it sees is going to be this one, so it's going to remove that one. But what if that's not the one that you want to remove? So be careful when you use this remove. I typically recommend .pop, but sometimes there are times where .remove is more convenient in terms of how it can make your program run, or just written a little bit better. So in this case, do we want to use .pop or do we want to use .remove? If we were to remove from the list. .remove. Okay, well, to be honest, it doesn't really matter for this one. You could use .pop and you could also use .remove. The issue, .remove might be the better move here, and this is the reason why. Let's say you use .pop. And we're looking at the indices. When we take a look at this 1 right here, we see, okay, it's an odd number. Don't remove it, don't pop it. But if you see this 2, which is at index number 1, and you say, oh, I need to remove this, and you use .pop, this will remove. Then you'll see that this right here is no longer index 2, but this now is your new index number 1. This is your new index 2, your new index 3, new index 4, new index 5, new index 6, new index 7, new index 8, new index 9, and new index 10. So everything completely changes depending, or once you remove something. Then after that, if you were going by index number, you might accidentally skip your new index 1 because you were currently working with index number 1 before that. So if you're working at index number 1 here. So this is where the issue of .pop and .remove come into play. If you're using .remove, you will be looking at the numbers inside of the list, like the actual values in the list. So you have a little bit less of a risk, but if you're not careful, you will run into the same issue where you can accidentally skip a number because you removed it and everything shifted over and you did not account for it. So let's try to see how we can, we'll probably do this one right here first, make an empty list. And then if we have time, we will try to solve this case where we use .pop and where we use .remove. For beginners, I always recommend doing this method number 1. But if you do want to challenge yourself, and if we don't, especially if you don't have the time to do this one right here, I strongly recommend that you try to figure this one out. Let's go ahead and figure out how to code this this example. You guys can see this? Okay, perfect. So in this case, we want to make an empty list. And then append all values that you want to keep, meaning you are removing all values that you don't want. But you're not really removing it from the actual list. You'll keep the actual list, but you hold on to, you only keep the values you want. So it's not really removing, you're just making a substitute list that will help you out with this. So here's my new list. Actually, let's say, you know what, let's go ahead and just use this list, but without all the negatives. Oh wow, it's like almost all numbers. For this one, do I want to use a for loop? Actually, let's go ahead and make our new list. So as I go through every single number in the list, and I have to check if it's even or odd, would I want to use a for loop, a while loop, or a for each loop? Let's go ahead and just relaunch this poll. So while loop, for each loop. Just wait for a couple more people to vote. Okay. So this one, kind of like the first example that we did, it doesn't matter which one you use because it you start like any, like you could start at the very beginning of the list, you could start at the very end of the list, and you just have to go through like all the numbers. So you could use honestly any form. A while loop or a for loop or a for each loop. So let's go ahead. Loop. But because you guys seem to like the for loop so much, we'll go ahead and use the for loop. So for each index from 0 to the very end. So because we're doing that, we're going to have to use range. So for each index in range from the very beginning of the list, which is 0, to the very end of the list, meaning the very last index, which is 1 less than the length of the index, we say the length of our list. So for index and range length of our list, we want to check if that number is even. So let's just say to get the number itself, the value of the number in the list, we have to access it using the index in brackets. How do I know if number is even or if number is odd? What do I need to use? Yes, the modulus. So you want to use the modulus. Modulus finds the remainder. So if number modulus 2 equals 0, that means it's even. And then we could say if it's not equal to 0, then this would be odd. So if the number is odd, what do I want to do? We want to append the number to our new list. Which is going to consist of us saying new list dot append number. What if it's even? What do I do? What if number is even? Right. If number is even, we don't do anything. So because we don't want to do anything, we just leave it alone as it is. We don't have to have an else statement. We just need that one if statement and that's it. So no else something, nothing else to follow up with. We're done. So if we just follow this algorithm and we print out a new list, you can see that from all of these numbers, only 25, which is over here, and 1 were the only numbers that were odd. So here we removed even numbers from the list by not actually removing, but instead what we did is just took the values that we wanted to keep to represent our new array or our new list, and we just held on to it. Everything that we didn't want, so everything that we figuratively wanted to remove from the list, we just excluded from the list. That way we create this illusion that we did remove a number from the list. So this is our method of doing so when we, oops. So if you were to do it again, but by using, let's go ahead and use pop first. From list. Pop. Pop with like the index number. Everything will look identical. So from here to here, or it seems like no. So unfortunately for this one, because we have to use dot pop, where pop uses the index number, we can't use any loop. We have to use a for loop or a while loop. You don't want to use a for each loop because a for each loop will get every single value, but it won't get you the index number. And the index number is what's going to be important for the function .pop. So, but everything else is identical. Also, because you are removing from the list, you actually don't want this. You know what, let's actually use a while loop because we use a for loop in the first one. Let's go ahead and use a while loop. So we'll just say while loop. So in a while loop, you're required to have 4 things. You need the initialization. Initialization. You need the condition. You need incrementation or decrementation, the updater, and you also need a the plan of execution. In terms of initialization, condition, and updater, it's almost identical to the previous one where in the for loop, because a for loop and a while loop, pretty much the same thing, it's just written differently and you have a different kind of syntax going on. So initialization, you start your index at 0 because that's the very first number you want to start off, or the very first position you want to start off at. You have a condition, right? So if the number, or if you have not reached the end of your list, so meaning if index is less than the length of our list, then you just keep running this loop. For the updater, because index starts at 0 and it should make its way up, it should increase and increase and increase, we know that we have to add 1 to index. And the execution should be similar to the previous program that we wrote, where you removed even numbers from the list, but instead of appending it to the list, we want to remove numbers from the list. So let's go ahead. So index, this is our initialization, is equal to 0 because that is where we start. And then while index is less than the length of our list, then you want to check if the number itself is even or odd. So number is equal to our list if the number modulus 2 is not equal to 0. So pretty much if you take number divided by 2 and you get a remainder that is not equal to 0, so we're saying if the number is odd, previously we wanted to append it to the new list, but we're not making a new list for this. We are physically removing it from our list. So we would do our list dot pop, and we are popping whatever value is at that particular index. So we just use index. The issue that we faced when we did this program, or when we briefly talked about dot pop and dot remove in a for loop form or in a loop form, is that when you do this, you remove it and then all of the other numbers, all of the following values will shift over, meaning you could potentially skip values. All the indexes will update. They will become 1 less because they shift over. So because all of your indices will update after you do dot pop, you need to also update. You need to make index smaller in order to compensate for the shifting of the indices after you remove something. And we saw that in the PowerPoint. We saw that in the PowerPoint right here. When we remove this one right here, what was index 2 has now became index 1. Right here, what was index 3 became index 2. So everything was offset by 1 smaller. Therefore, we're going to do that as well to our index marker. But this only happens if you actually have to pop something from our list. Then after that, so we completed the initialization, the condition, the execution, and now we have to implement the updater. So at the very end of the while loop block, we should update our new or update our index to add one. So if we print our new list, oops, what did I do? Our list.pop index. Oh, we want to pop even numbers. Sorry. So we want to do if it is even, not if it is odd. So this is a little bit different. This one we wanted to do what we want. This is what we wanted to keep. So if it's odd, we want to keep it. And this one right here is just what we want to remove. So if the number is even, we want to pop it. If we want to remove it. Notice that this is a correct value, but if I had decided to do, let's change this to 83. So if I comment this line of code out where I don't change the index, we can see that everything kind of just goes crazy. We have numbers that are not to be in there appear inside of our new list, our updated list. That's because we didn't do that index offset. So you're skipping numbers. You're not checking all the numbers like you should be. So make sure that if you are physically going to remove things from the list, that you check that your indices are being updated properly as you go through it. Any questions?